Hello everyone. So today we'll continue from where we stopped in the last class, and the last class we were trying to set up Dojo and deploy our contracts. So we'll continue from there today, and by the end of this class you'll be able to build a full-fledged working Dojo game, right? So I built a very simple but fun game that we are going to follow along in the course of this class. So you can test out the game and just see the mechanics and how it works. So if you want to play the game, just go to chasethebag.vessel.app. So it's a very simple and fun game, but it teaches you the basics of Dojo, of building games with Dojo Engine. It teaches you how to sync your world data with Torii. It teaches you about players, actions, and a couple of other fun stuffs. So this is what we'll be building at the end of the class. So as you can see, I have a couple of accounts here. If I connect to the first one, though I've been playing the game before, but you can actually see that I have 16. I have a score of 16. So it's called Chase the Bag. It's basically you navigating the grid using the arrow buttons in your keyboard, and once you hit the bag moves to a random position on the grid. So that is how it works. You just continue chasing the bag till you feel like you've gotten enough bucks, to not have to work anymore. But yeah, so this is it. If you can look at the score here, you can see that it's increasing, right? So anytime I chase the bag, my score actually increases. So you can see that when I hit the bag, my score increases, and the bag moves to a new random position. So this game was built using Dojo Engine, right? And both the contract and the front end was built using Dojo.js. So without further ado, let's get started. I believe by now we might have set up our environment, right, for developing with Dojo Engine. So I'll just come over here, open a new. Let me just. This guy is blocking my terminal. Okay, let me just create a new Dojo project, and I'm gonna call this. Chase the bag. But in this case, we are not just creating a Dojo contract. We are actually creating a full stack Dojo game, which means that it involves our contract and also the front end. So the command we use in this case is different. We'll build it from Dojo.js, right? So Dojo.js has like a template that you can use to generate boilerplate for your front-end Dojo games. So let's pull it out real quick. Dojo.js. So this is the official documentation, but as you can see, right over here, the default template is React SDK, but there are a couple of other boilerplates, example boilerplate that you can use, right? You can use React, you can use the kitchen sink, you can use the React SQL if you want to use SQL to query your Dojo world, right? So currently, right, for this React, you guys will see that we are using the query builder, right, to generate a query. But if you want to use SQL, you can use this template and just check it out and explore each of the templates. So what this command will do, right? It's going to download a Dojo boilerplate for us that contains both the contract and the front end. So let's name this chase debug. So it has downloaded the client and it has downloaded the contract. So this means we are good to go. So let me quickly open this up and oh yeah, chase debug. So yeah, this is our Dojo project, and the first thing we are going to do, right? Okay, the command is here. You can just go to your browser, search for Dojo.js. It's not bringing it out, but just go to this URL, right? dojoengine.github.io/Dojo.js. Then the command is at the top. It's the first. You're there, right? Is it the one? Oh, okay, cool. So, yeah. So the first thing we'll be looking at, right, is our contract. You know, I told you that your contract is like you're in the Dojo ecosystem, in the space of fully on-chain game. Your contract is similar to how you have your backend API, right? Your backend APIs, your REST APIs, and you know, all of those stuffs, right? In a regular Web 2 game. So let's open the contract and let's see how we can modify the logic to fit into what we want to achieve. So I'm going to split this, moving to contracts. So the first thing we are going to modify here is the models. Though the models look quite similar to, you know, what we'll be building, right? Because the default Dojo project, right, comes with something similar. So the first thing we'll be doing is to modify the model, but for the sake of time, I'm just going to paste the existing code, and I'm going to walk us through it. So let me just confirm something. Let me just verify that this project built. Oh, sorry. And let me verify that. Okay, after building, I'm going to check for the test. It passes. So this is the first thing you want to do actually. You want to verify that, okay, you're starting from, you know, a working project, right? So before you start modifying anything. So as you can see, this project built. Let's run the tests. There's a couple of tests here, a couple of default test cases. So yeah, 4 tests are passing, means we are good to go. So the final code for chase debug game, right, is on GitHub. It's open, and you can go and, you know, clone it and check it out, right, while we build it in the class, right? So github.com/. No, this is not what I named it. Yeah, Dojo Game tutorial. yeah, so this is the code. So the fact that I already have most of the stuffs here, so I'm just gonna copy and paste it, and then explain it. So the first thing you want to work on, right, is your model, because without your models you can't have like a structure or whatever you want to query from your actions, right, altogether. So the first thing you want to work on in your Dojo contract is your model, right? So over here, this is our model. Now this is our model, right? So the first thing I want to show you is the player model. Now this player model, right, contains details of each of the players in our game. So when you come into this game, you connect, if controller is active, you connect your controller, right? It's going to save your controller address to this player field, and the score, right? The score is what you're seeing here. So for each bag, right? For each bag you claim, is going to increase this your score, and this next bag, right, is where is the location of, I mean the position of where the next bag is, right, on this grid. If you look at it, whenever this player comes and, you know, hits this bag, the bag is going to move to another random position, right? So if you look at it, it's going to move to another random position. Yeah, so that is what this next bag is, right? It basically tells the player where the next bag is. So now position is another model that I want you to look at, right? Position contains the player address and their current position on this particular board, right? So now this position has like player, which is the player address, and a vec, which is a vector. This vector is a custom struct. So if you look at this vector now, this vec2, right, it has x and y. So what does it mean? It means every player, right, must be in a particular position at any given time, and that particular position is defined inside this vec field, right, altogether. So now look at this player. This player is in this position, which is, if you look below here, you see that the position of the player is being stated here, right? For this player is in 3,6, which means 0, 1, 2, 3, and 6 from the top. The 6 now is the y-axis. So the first one is the x-axis and the second one is the y-axis. So if you look at it, it starts from 0, right? So 0, 1, 2, 3, and 6, 0, 1, 2, 3, 4, 5, 6. So if the player moves, the position changes to a different position. So as you can see, it's now at 4, 5. So it means on the x-axis, it's at position 4. On the y-axis, it's at the player is at position 5. So this position model, right, is what keeps track of the current player's position, right, altogether. Are you with me? So now direction is an enum, right? If you look at the player's movement, you can see that the player can only move in 4 directions, either up, down, left, right. So that is what is enum for. It is used to define the limit of movement of the player, right? Because this is like a world, you know, every dojo contract is a world. So think of it this way: if you are creating a new world, you have to create the limit and every form of restriction, right, in that world, right? So that is exactly what we are doing here, and this is the vec2 custom struct that we just talked about. So we might not be using a couple of these other guys right now, but yeah, it's good to also check it out. Now, after we're done with our models, the next thing I want us to check out is our actions. So yeah, similarly, I already have the actions I already have the actions defined here, but you can check out this repository and see the full code and see the full code base, right? So let me quickly open the actions. So I'll just quickly explain through these actions and show you how it works. So these particular actions, right, determines every logic that our game can execute, right? So if you notice, right, as a player, if I come here and I move close to the bag, and as soon as I get the bag, just notice what will happen, right? The bag moves to a new position, right? So this particular logic of the bag moving to a new position is being defined inside of our actions, which is what we have here. So let's quickly go through it. The first thing we have is our import, right? We are importing the direction and the position models. Secondly is interface, right? So you know, this is similar to a Starknet contract. So just like how you create interface for your Starknet contract, same way you create interface for your Dojo contract as well. So as you can see, we have two functions here, the spawn and the move function. Now the spawn function doesn't take any parameters, and the move function takes the direction. So this direction tells it tells our actions, or it tells this particular move function where the player intends to move to. Right, all together. Are you with me? So yeah, this is our main actions file, actions module, sorry. So you can see a couple of imports. You can see, yeah, this is us importing Starknet contract address, block timestamp. So I'll quickly jump into the so just one thing I want you to notice, this model storage and event storage should always import model storage. Altogether, this is very important, please. You should always import model storage and event storage if you want to read. For model storage, if you want to read and write your model, make sure you import it. For event storage, if you want to use event, right, in your contract, make sure you import it, because without it, your code is not going to compile. So this is an event that we created. As you can see, this is what we used to indicate that this is an event. So it's a moved event, right? So what happens is whenever a player moves, this event is emitted, right? And if you look at this guy here, now if you look, as soon as I move, this position and stuff is being updated immediately. Just look at it. By the way, I'm using the arrow keys on my keyboard to move. So up, left, right, down on my keyboard. So you can see that this guy is always changing. It's always changing. It's always changing, right? So that's part of the usefulness of this move event, right? If you want more customization, you might customize it such that you know do something more fun with it. But just know that as soon as you move as a player, this event is being emitted, right? So let's move on to the implementation. So of course, this is implementing the actions interface. Now let's take a look at the spawn function. If you look at the spawn function, the first thing we're doing is getting word default. Now this word default is an internal function, right? So what it does, basically gets the word. It basically gets our Dojo word using the namespace that we define, right? So if you look at this namespace here, right, you can see that it's the same thing that we defined in our namespace section of, no, it's not here. Namespace here, you can see that this is what we defined here. So we want to get the word that is located in this particular namespace. So that's why we created this internal function. So yeah, we use that to get the word, and with this word we can read and write to our models. So the second thing we want to do is to get the caller address, because we'll use that to, okay, no, sorry. We're talking about spawn. Okay, so concerning these red lines, right? You see the language formatter, right? I think it didn't come with it. Let me see if it's here. Yeah, I don't know. The language server is not. It doesn't work by default. All right. So the red line is something you should expect. I said, yeah, it will compile. Your main issue, your main focus is if you run scar build, just like what we did some minutes ago, and your code compiled. Right, that's the most important thing to you. These red lines might always be there because the language server for Dojo Engine it's not yet full-fledged yet. It has not been completed, so you might get because this is currently using the Cairo language server, which you can see it's throwing a couple of stuffs here. So the Cairo language server does not fully understand the Dojo contract yet. So I believe it's a work in progress, but you can maybe check. I believe probably by now they might have made significant progress, but you can check and see, on your own how probably if it's possible to work around that. Okay, now this is what I want to show you, right? In line 37, we are reading, right? If you notice, we are reading from the player model, right? Passing the caller address, but we've not created any player yet. So what does that mean? It means by default, right? Just like how mappings in Solidity work, all of your models, right, have all of the keys initialized by default to their default values, right? So for every address you pass in here, you are going to get a player, but the other fields will be initialized to the default value. So score will be initialized to 0. Next bag will be initialized to the default values of vector 2, and vector 2 has x and y, right, which are u8 each. So u8, of course, the default value is 0. So all of the fields will be initialized to their default value. So over here at line 39, we are checking to verify that this player has not, we're checking to verify that this player has not spawned before, that this player has not called this function, because you can only call this function once. So once you call it, right, once you call this particular function, you are not expected to call it again. Now, this is what spawning a player simply means to our models, right? First of all, we are creating a new player struct to be saved in our model, and over here you can see that we are setting the default value to be 1. We are setting the initial value, sorry, not the default value, initial value to 1. That's why we're able to check over here to verify that it is less than 1, because as far as this guy is equals to or greater than 1, it means this particular line has been executed on this player's address, so it means this player has called this particular function. So yeah, then this is the next bag, which is us initializing the initial value of x and y to be 7 and 0. Why? The reason why we are doing that is because now let me spawn a new player and show you how it looks like. So I connect to a very new wallet. Okay, no, this guy has spawned. Let me connect to Katana tree. This particular address has not spawned before, so as soon as I spawn, you are going to see that the player's position is at the starting point and the bag is at the end point. So it is because of this particular statement here, right? So we are setting x to be 7, which is what you see here, and y to be 0. So 0 on the y-axis, 7 on the x-axis. So yeah, the player position at 0 at x-axis, 0 at y-axis. That's why this particular player is here. So are we together? Are you with me? Is there any question at this point? So yeah, we created 2 structs, player and position, in order to update our player and position model. So this is where we are doing the updates, right? Just to remind you, right, as anytime you run, you execute word or write model, it actually emits an event. So it's not only when you call the moved, we'll get to this place, but it's not only when you call this particular guy here. It's not only when you call the word.emit event that event get emitted. Also, when you update a state, when you create or you update a model, an event is emitted. So that is it for the spawn function, and let's proceed to the move function. So yeah, similarly, we're getting the world in line 52 and line 50. Okay, line 50. Okay, line 54, we're getting the caller address, and in line 56, you'll notice that we are getting this player from the player model, this particular player. But notice one thing. Notice we have a mute keyword here. So what does this mean? It means we want to modify, we want to mutate these players, these player details in the model, in our model. So the first thing we want to check is to verify that this player has already spawned. So we'll check to see that, okay, the score of this player is greater than 0. And the next thing is we will read this player's position, right, from the world. Now the next thing we want to do is we want to calculate the next position, right, as soon as this player moves. Based on the direction that this player wants to move to, we want to calculate the next position this player should be, right? And in order to do that, there is a function, an helper function, an internal function. Yeah. Okay, this is not an internal function actually. This is an helper function. Now this particular function, what it does is it calculates it gets the next player position, right? So what it means is if a player moves left, it's basically deduct 1 from the x coordinate of the player. If the player moves to the right, it adds 1. If the player moves up, it deducts 1 from the y coordinate. If the player moves down, it adds 1 to the y coordinate. So that's why you are able to, if you look at it now, I moved down, right? So initially this guy was 0, but it's now 1. If I move right, the x coordinate is going to change. Let me move right, you see it. So 1 was added to the x coordinate. And if I move left, I move left on my key, 1 was deducted from the x coordinate. So you can see that is how this works. That is the life and purpose of this guy, this function called get next position. All together, are you with me? Is there any question? Now this, after getting the next position, right, the next thing we want to do is to update that player's model, update that player's detail in the position model, right? So that's what we're doing here. We're writing to the position model, updating this player's details. So now this is something very important, right? Super important. If the player is in the process of moving, right, you know, the player moves, you know, and the player moves and move and move and move until he gets to the bag. So we need to define what will happen as soon as the player hits the bag, right? So over here from the game, you can see that as soon as the player hits the bag moves on to the bag, changes position to a new position entirely, and the player's score increases by 1. Yeah, so now so it is when the move function is being called that we also check for what happens when the player hits the bag. So after updating the player position, that is changing this position to wherever it's supposed to be, the next thing to do is to check if the new position, right? That's what we're doing here. We're checking if the new position is equals to where the bag is at the moment. right? So that's what we are doing by checking next position.vec.x equals to player.nextBag.x. And similarly, are we together? Are we all together? Are we together?
Yes, sir.
Okay. So, yeah, we are basically checking. Okay. So we are basically checking to see that the player actually hits the bag at this point in time. So if the player hits the bag, right, which will allow this expression to be true, right? So if this expression is true, the next thing to do is to get random position. Now getting random position is what happens when I hit this bag and this bag that is here moves to an entirely new place. Wow, where am I going to? Do I really want this bag? So yeah, as soon as I hit this bag, right, it means the player is, it means a random position is being generated. So let's try that out. Now it was here and it's now here. So that is what this particular function does. Now, as you can see, we are passing in the player. This is the player struct, or let's say the player model. So let's check get random position and see what this particular function does. Yeah, so let's check this out. It's an internal function. Now look at get random position. What it does basically is that it generates two random numbers, right, within the bounds of our of the size of our board, right? In this case, it's an 8x8 board, so it generates random numbers between the bounds of 8x8, right? Two random numbers. So one is the x coordinate and one is the y coordinate, right? So now, there's one important thing you need to take note of, right? In this get random position. So what happens is over here I'm looping. And why am I looping, right? I'm looping because, yeah, so I'm looping because I don't want a situation where, you know, a random position is generated, right? And that random position happens to be where the player is, right? So it's not going to make for a good game mechanics, right? Because think of it this way, as soon as I hit this bag, and the bag just disappears. Meanwhile, it didn't disappear, it was just under this, it was just in the same position as the player. So that is why I'm looping, such that if I happen to get, you know, a position that is the same as where the player is currently, I will just skip that particular number and generate another one. So that is the essence of this loop here, but let's break it down. We have a mixer, we have X and Y. So we're using get block timestamp, you know, as our seed here, right? And I want you to know one thing, right? I'm using the dice traits from, this is how I got access to the dice traits. Right, if you look at my scarp.tommy, you will see where I added it as, I've not added it over here, so let me quickly add it from here. So let me just replace whatever I have here with this. So yeah, if you look at my scarp.tommy, you can see where I added origami random, right? Now origami is like a suite of utility functions or tools that you can, easily use in your game, such that you don't have to write it again, right? Like for instance, generating random number. We all know it's something that is common among most games. So Origami provides a dice trait that allows you to just generate random number. You can check out more of, you can check out more of what is contained in Origami if you come over to, libraries, Origami. So if you come over to get to this particular section of the documentation, you can see more of what Origami can do for you. Like in my case, I'm using the random, this is what I'm using. So you can just check out and see more of the utility functions that Origami provides for you. So I imported that in my scarp.toml in the dependency section, and I now imported dice trait from here. So this is how I imported it from Origami random dice and dice trait. Now what am I using this dice trait to do? To get random numbers. All together?
Yes, sir.
Are you with me?
Yes, sir.
So this is how you get random number. You cut the dice trait, you pass in a face count, right? So let's now you can if you check, you'll notice that I passed in another. The dice trait takes in two arguments, takes in the seed, it takes in the face count and the seed. Now if you notice, I added something called mixer, right? What this mixer does is, right, it basically mixes the random number. It adds more randomness to it. And why am I doing that? I'm generating two random numbers in a single transaction, right? And I'm using the block number as the seed. So what this means is, if I'm using the block number as a seed, it means no matter how many times I try to generate a random number, it will still give me the same number, right? As far as I'm using the same seed, it will always give me the same random number. Are we together?
Yes, sir.
It will always give me the same random number. So what I'm doing is, I'm using this mixer, right, to further mix the randomness such that I won't get the same random result. So if you can see, I added a seed plus mixer, I added a mixer, seed plus mixer plus 1, and on each iteration, right, the mixer increments by 1, so the mixer is never the same. So if I happen to loop over this in the same transaction, the mixer basically makes this guy generate new random number for me on each loop, right? Are we together? So I got two dice trait instance, and this is where I'm rolling those two dice to get the values. And so over here I'm checking to verify. Let me just add that. So if new dice position is not right in, okay, let me see, let me verify this logic. So it says x is not equals to player.nextBag.x. Now of course the next bag, right, it's where the next bag is. So we are basically checking if it's not the same as the current. Okay, so I think we need to add more checks to this, but the idea is to verify that that the current, that the new position, right, generated for the bag, right, is not the same as where the current bag is, right? So that is what this guy is doing at the moment, but we can still go further on to add more check to verify that in as much as it's not where the current bag is, it shouldn't also be where the player is at the moment. So we have our mixer, and this is where we return the two values from random position. Are we together, guys?
Yes, sir.
So after getting our random position, yeah, this is our X and Y values. So you set the next, the position of the next bag of this particular player over here, and you also increment the player score by 1, right? And also over here you update the player model. And lastly, you emit an event. So that is what happens when you move, right? So two things happen. It basically changes your position, and it also checks if the player hits the bag. And if the player hits the bag, increments the player's score by 1, and also generate a new random position for the bag. So that is what the move function does, right? So that is, I think that is all for our actions contract. It's a very simple but fun to write contract. So the next thing we are going to do now is to write the test. So I've already written the test, but let me just so you can always check out the main repo on GitHub. So yeah, this is the test, and let's see, Git repositories were found. What did I do? Wow. Okay, would you like to open the repositories? No, let me just ignore this. So yeah, let's jump right into writing tests for our Dojo contracts. I already have the test here, so I'll quickly walk through it and show you guys the important part of it. So now this is, so yeah, these imports are like super important. Model storage, word storage, straight word. So you'll see why, because we're making use of, we are reading from the word here, so that's why we also need this word storage over here. And you also need to import these guys too, because spawn test word basically deploys your contract, and also your models, and also it also handles permission as well. So there's a namespace, test results. Just make sure you have all of these stuffs imported, so that your contracts, your test can run successfully. Now, this is one that we might be familiar with. This is line 9 is one line we might be familiar with. If you look at it, we have our actions dispatcher, and actions dispatcher tree. So you are getting access to okay. The first thing is we are importing the actions, right, which is what we created here. And we're importing the dispatcher. The dispatcher and dispatcher tree gives you access to the functions, right, inside the interface. Right, you guys have done testing, right? You must have come across dispatcher and dispatcher traits. So talking about the models, right? Now this might seem weird because in our models we didn't define anything like M position or M player, but we define position, player, and direction. Right? Are we together?
Yes, sir.
But M position and M player, right, was not imported. So the idea is, as far as you have a position, right, a position model or any other model, you in your test, right, you have access to an equivalent of it, right? This is the model, right? But this is the equivalent of it that we can get a class hash from and register and use it to register the model, right? Same as player model and end player, which came from the player model, right? But we didn't explicitly define this, but just know that you have access to it inside your test. Now, so this is where we actually register all of our resources, right? Are you with me? This is where we register our resources, right? As you can see, we have the position. Now we have model, we have event, and we have our main contract. All of these are our resources. So this is how you register your position model. This is how you register your player model. And if you have any other model, right, whatever the name is, you just simply add an M underscore. So you simply add an M underscore followed by, if this is leaderboard, you put leaderboard. Yeah, so after importing it, you come here and you register those models, and this is how we register our event as well. You have to register your models, you have to register your events before you write tests. Are you with me? So after registering the event, the next thing to do is register the contract as well. And we are registering it under this namespace Dojo Starter. So this is basically handling permissions, right? You know, if you go to scap.toml, we define the permissions for our actions and the permissions that exist between our models and our actions, right? Let's check it out. If you look at, okay, no, this is not where the permission is. The permission is in the profile. Now, if you look at this particular line 25 and 26, this is where we define the permissions, right? So what we're saying is, so basically what we are saying by this permission, are we together, guys? Are we together? Are you with me? So what we are saying is all of the functions inside Dojo Starter actions. Now, you know, these actions is whatever we have here, and Dojo Starter is our namespace. So it must actually match with your namespace and your action. So you are saying whatever functions you have inside your Dojo Starter actions, you'll have access to all of the models inside Dojo Starter namespace, right? So that is the permission we defined, but you can check out more about permissions and how you can create custom permissions if you come to authorization. Yeah, just check out this part of the documentation. You'll be able to see how to create custom permissions. Like for instance, now this particular line here is saying, okay, all of the functions inside, okay, yeah, it's similar, right? It's saying only the directions available model. So it means these actions, right, can write to the directions available model, right? So are we together, guys? So now that is similar to what we are doing over here in our test. We are trying to create permissions. As you can see, we are specifying the actions inside our Dojo Starter. So there's one thing, this is not part of the boilerplate, but this is something that I love to do. I love to set up world, right? I love to have a function called setup world. What this function does is it basically sets up the permissions, and it basically calls this guy and the registers the resources, sets the permission, and also creates a contract instance. So what does that mean? It means I can easily come here, I can easily call the functions from inside my contract by just calling this action system that got returned from my setup word function. So it's for simplicity. You can also adopt the same. Adopt the same pattern. So yeah, this is basically read permissions, setup word, and this is like me getting an instance of my contract, right? Using the actions dispatcher and passing the contract address. So what I'm doing here, I'm returning the world, and I'm returning action systems, which is like access to all of the functions inside my contract. So this is the first test we have here, test move, and what I'm going to do is I just want to check to verify that when we call the move function, it actually works. So first thing I'm doing is I'm getting caller address, right? But okay, first of all, let's run this test and see. So this test is passing, right? But I'm going to be doing something. Instead of generating a random address or generating a constant address, I'm going to show you how you can set your caller address, right? So in case you have you want to like control the caller of a particular function in your test, this is how you can do it. Just now the documentation has a lot of these utility functions you can use, right? So testing cheat code, yeah. So this particular function here, set caller address. So yeah, this particular cheat code gives you access to set the caller address, right? So you can maybe, when calling different functions or a particular function, you can explicitly define the address of the caller, so you can verify that the result is what you're expecting. So let's import testing from Starknet. So let's do something, right? Let's first of all, we should have imported this guy, but let me see. So let's import get caller address and testing. So let's come to this particular line and get the caller address. So after getting caller address, we want to set the caller address to be this particular caller. So what it means is, from this part to the end of this test, this particular caller will be used as a caller address. So what we want to do next is to spawn, and if you look at spawn actually uses the caller address to create a new player, right? Yes, so if we call spawner, it means it will use the address of the caller to create a new player. So what we want to do now is to, so we've made a state change, because spawn makes a lot of state changes. So we made a state change. Next thing we want to verify is, see that that state change actually took effect, right? So similarly, we'll read this player from the player model, read the player position as well, and over here we'll compare the player position. Now, okay, well, first of all, check the score. You know, the score is, when you spawn, right, the score is 1. You know, when a player spawns, by default their score is set, their initial score is set to 1, right? So we want to verify that this player's score is 1, and the X and Y position, right, of this player, which we set as 0 over here, we want to check that they are still 0. So the next thing we want to do is to move. So now let's say move up, for instance. Okay, let's just leave it as down. But you can actually move to, you know, different direction, right from your test, and this is how you do it. So yeah, this player wants to move down. So moving down is equivalent to what I do when I click on my down button here. So after this player moves down, we want to get the new position of the player. And after getting the new position, right, so it's like basically the position of the player after moving. So after moving, we expect, because over here, when from our logic, we say when the player moves down, this is down, right, increment the Y coordinate by 1. Are we together? Yeah. So over here, we want to check that the new position, the Y coordinate of the new position is equals to the Y coordinate of the previous position. This is the previous position before move. So we want to check that the position before move is +1, right, equals to the new position. And X still remains the same, because when you move down, you don't alter any coordinates on the X axis. So are we together? Let's run this test again. Are you with me? Are you guys with me? So this test is passing, right? Test, let me see if, well, we can also test spawn differently, but the fact that we're using it in the move also makes it valid. But you can add more test case to your test function. Now, is there any question pertaining tests? Do we have any question pertaining tests? So that is it for our Dojo contracts. So what we are going to do now is to move on to front end. Sorry. Okay, yeah, this is the import section.
Why is the end position highlighted red?
So as I said earlier on, the Cairo language formatter does not fully understand Dojo contracts yet, but I believe it's being worked on to understand that this particular guy and this guy, they are supposed to be here, right? Because in your test you have access to your, because it is from this end position that you can get your your class hash of your model. So yeah, you have access to it from your test. So whichever model you have, no matter what model it is, leaderboard, achievement model, it means you have access to m underscore, the name of that model. So this is where it is being used. Did you try it from your end? Okay, so currently it takes around like maybe takes just a very short while, to, because you know every move you make is a transaction, right? So currently it takes a short while, right, to execute that transaction and analyze it. So that's why you're experiencing that lag. But the dojo team is the thing is the dojo team are working on something super exciting that make you get like instant feedback, right, or instant transactional execution. They're working on something like that, and to release probably in the nearest future. But yeah, just know that that lag, but there's a workaround for that, which is using optimistic updates in your UI, right? So you can use optimistic updates such that whenever such that immediately you make any action, you take any action, it will update your UI before sending that transaction to the blockchain, right? So as soon as you take any action, you will see the changes reflect, and it will send the transaction in the background. So this is how it looks like. Yeah, this is how it looks like. Optimistic updates. Yeah. So it basically updates your UI before calling that particular function from your contract. But yeah, currently there are like a couple of ways around it actually. Another way you can, if you don't want to use optimistic update, right? Another way you can use is to maybe in your UI you update it manually. You target that particular entity, you update the value, and you just send the transaction in the background. But when the transaction didn't go through, you also make sure you revert the changes you made. Just like similar to how it is done here. So we'll dive into the client shortly, but let's wrap it up with the contract. So this is it for our contract. Is there any question? Does anybody have anything they are not clear with? So yeah, let's move on. The next thing we are going to do is to deploy these contracts locally. So let's do that. Let's deploy this contract. So let me see. Let me just simply copy the command to deploy Katana. To spin up Katana, sorry. So yeah, this is it. So yeah, as you can see, we are spinning up Katana, and we are spinning up Katana in dev mode and applying this no fee flag. Means transaction should execute freely without any fees. And this last flag allows Katana to be accessed from basically our front end, right? So let's spin up Katana. But before, let me do that again. But I want you to know about the Explorer, right? If you add this Explorer flag while spinning up Katana, it will give you access to a local Katana Explorer, right? So this is how you can. This is where you can access the Explorer. Yeah, this is locally, and this is based on your Katana. This is based on the contract you deploy to Katana. So what it means is you can come and interact with your contract. But let me deploy. So I'm going to be using this scab. If you take a look at the scab.toml, there is like a script there. So it is that script that I just run. This migrate script means sozo build and sozo migrate. So you can actually add more scripts if you. So the difference between build and migrate. So build is generating the artifacts, right? Just like generating the artifact necessary for deployment, right? While migrate, right? One of the things migrate does is it deploys your contract to this local Katana here, except you specified an RPC URL, a different RPC URL over here. But yeah, it deploys your contract to this whatever RPC URL you specify. In this case, our local Katana, and it does other stuff, right? If you notice the logs, right, while it was deploying, it registers or word sync permission, registers the models and resources. It does a lot of things as well as deploying your contract. So that's what migrate does. So what you do is, I told you Dojo is a profile-based system. So what you do is you simply create another profile, Dojo Sepulia, if you want this to be on Sepulia. So you basically copy all of the stuffs here, you paste it here, and you just create a unique seed, because definitely somebody might have taken this seed on Sepulia. You might just Sepulia Minet Sep V1. Then this is the most important thing. You change this to the Sepulia, the cartridge Sepulia URL, RPC URL, and you can get that from here. So yeah, if you want to deploy to Sepulia, you get the RPC URL from here, paste it here, and yeah, you won't be needing these guys because you'll be setting them in your environment variable, right? Which will be sepul.env.sepulia. So basically, in that environment variable, what you do is you simply add these guys here, and you replace this with the provider. The provider is what we just saw not too long. The provider is this guy here. This is the provider. Then this is your account and this is your private key. So you can come to your Bravos or Agent and you fund your wallet with Sepulia tokens, both Stark and ETH. So after you fund your wallet, you copy. Please don't use your. Well, I'll be showing you guys actually. So I'll be showing you guys how to deploy the Sepulia. Though, but just know that you shouldn't use your main wallet. You should create like an auxiliary account for that, maybe a dev account, because what it means is you'll be exposing the private key and the account address over here. So of course, with your private key and your account address, anybody can move your funds. But yeah, I'll be showing you how to deploy to Sepulia if we have more time. right? But let me just deploy this to, let me deploy this to Torii shortly. No, I've already deployed to Katana. Let me actually index the word data with Torii. So I'm just gonna pull that command as well. Then for the word address, simply copy this word address and use it. So as you can see, Torii is now indexing our Dojo world. And as you can see, our models have been registered and our events have been registered as well. And as you can see, this is the WebSocket configuration. So all of these things are done for you by default. What it means is you don't need to do it on your own. So this is like one of the benefits of using Torii, because you don't need to configure your web server, right? I mean, your web server, your WebSocket, all of these things are already been done for you. So yeah, our contract is deployed and we are now indexing our word data with Torii locally, both locally. So the next thing we should do is to take a look at our client. So we've done like most of what you do, right, for local development on your contract section. So now let's move on to the client. The first thing I want you to take note of is your package.json, which is like the main file. This is a Vite React app. Of course, you know we were using the React template, right? So that React template actually gives you a Vite app. So yeah, the first thing I want you to note is these versions. As you can see, we are using the latest version of the Dojo Engine SDK, both Torii client and a lot of other stuff. So if you're having any issues, you might just check to verify that maybe you are in the version you're supposed to be, or you are in the latest version. So the next thing I want you to look at is Dojo config. Now if you look at Dojo config, you'll notice that we are importing manifest dev.json from manifest. Okay, from our contract section. This is very important, please. So you should take note of this. We're importing manifest dev. Now this manifest dev was automatically generated. It's not your obligation to code this. As soon as we migrate our contract, and this dev means the profile. So if we migrate our contract using the release profile, this will now be manifest release, automatically created for us. Manifest release like this. No, I'm not supposed to update this. Let me just change it back to manifest dev. Yeah, they have a documentation. This is the documentation. This is the Dojo.js documentation. So whatever you're looking for, you definitely see it here. So yeah, we're talking about. Okay, if you look at the manifest, this was, as I said earlier on, this was automatically generated for us, right? So we, in our clients, let me just close this, guys. So in our client, we are basically, yeah, you have a question? Now that is one of the good thing about fully on-chain games, right? There's no database here. All all of our data is being indexed in Torii. So whatever happens, right, all of these guys you are seeing here, we are not reading any data from a database or something like that, right? We don't have any maybe indexer we built ourselves. All of this is being powered by Torii, right? So Torii indexes all the data in your world and makes it available for you. Yeah, Docker is probably when you want to. Though I've never this Docker file came with the latest version. I've never had to use it in any of my project, but let's check it out and see what is. Let's see the content of it. So basically, probably if you want to like host Dojo engine on an isolated environment, maybe like a container, right? Maybe if you want to run it from a container, right? That's why the team actually set up a Docker boilerplate for you to use for that. So Dojo.js.config is like one of the most important files in your client, right? Are we together, guys? So it's like one of the most important files in your client, and this is so if you want to your client to read a different read from a different profile, you should also update this. Probably if you want it to read from release or Sepolia or mainnet, so you should use so it will basically read from whatever was generated from here. So another thing I want you to take note of is this create config, right? It takes in RPC URL. No. It's not coming up. So one thing I want you guys to note is this guy now, this creates Dojo config, takes in Torii URL, right? And Torii URL is, in our case now, we are running it on development environment. So our Torii URL is this development Torii, which is available on port 8080. If you run Torii, you see our Katana is available on port 5050 on localhost, while Torii is available on port 8080 on localhost. Look at it. So now the reason why it was not explicitly here is because by default, right, behind the scenes, right, they've already, inside this create Dojo config, they've already set it to read from local Torii and local Katana by default. But if you are deploying this, if you want to move on to maybe release or Sepolia or mainnet, you should definitely specify your Torii URL, right? So I can explicitly put local Torii. I don't know why this is not recommending. Oh, wait, have I installed? Oh, I think I know the problem. I have not installed the packages. Yeah, I've not installed the packages, so that's why it's not recommending anything for me. Well, let me move to clients and install the packages. So after installing the packages, yeah, these are the variety of options. Torii URL. Now I can explicitly say local Torii, because local Torii is localhost at 8080. This is like explicitly defining it, but by default it's there for us. So your RPC URL, oh no, RPC URL, you can also say local katana. So these are like the constants that are available for you inside of the Dojo engine core, right? But if maybe you host this in, okay, let's say this is on Sepulia now, what you are expected to do is to replace this Torii URL with Sepulia. You are expected to replace this guy with this, right? And use some minutes. But yeah, since we're on local environment, let's leave it at the explicitly defined local katana. So that's one important file. So let's dive into our source directory. Now let's look at main. Now let's look at something important here. If you notice, right, over here in the configuration, in the init function, we're passing in the word address, right? But the word address was gotten from this guy here, from our manifest dev, word.address. This is our word address. So the fact that we were importing it from Dojo config.js inside manifest, so it means manifest is like that old JSON file, and that's why we have access to it over here. So yeah, the first thing you do is you create a provider that wraps around your project, a Dojo SDK provider. Dojo SDK provider has been imported from Dojo Engine SDK. Yeah, Dojo Engine SDK. So inside this provider is where you set up your configs, right? Like the SDK, the Dojo config, right? This is Dojo config, the one over here, and setup world. Yeah, so setup world, we'll get to this shortly, but just know that for now, just know that this is auto-generated based on your contracts, based on the functions inside your contract, right? This is auto-generated. Just know that for now, but we'll get to it shortly. So this is how you configure the SDK and you wrap it around your app. And Starknet provider, of course, is similar to what we're already used to in our regular front end. Right, so Dojo.js is like you wrap around Starknet.js. It just makes it easy for you to, send transactions to Starknet, right? So this is the Starknet provider. This is how you configure it. Now, I just realized there's something that I didn't tell you, or maybe I did, but I didn't emphasize on it. You see this particular part where we were getting random position, right, altogether, right, in product, because it's a dev environment, that's why we are using the dice trade, but in a production environment, you should use cartridge VRF. Are we together? Now, in a production environment, you should use the cartridge VRF. So the cartridge VRF generates random number, verifiable random number. So instead of using this dice trade locally, right, you should use the cartridge VRF to generate random number, right? So you can see it's only available on Sepulia and main, and that's why you couldn't use it locally. So yeah, just check out the docs, and it's super easy to follow, right? Just have your contract and add the request random and consume random function, and you'll be able to get access to, you know, verified random numbers. So yeah, I use cartridge VRF in a production environment to get random numbers in your game. So let's go back to Starknet provider. Now in this Starknet provider, you notice that we're using pre-deployed account. Why are we using this? You know, in a production game, right? A game maybe on testnet or mainnet, right? Like this game, for instance, right? You have to, like this particular game that we built, for instance, right? You have to use something like, okay, you have to use something like controller, right, to access. But over here locally, right, we can't, though you can use controller locally, but we won't be able to explore that today. I'm not sure if it's really stable yet. Let me stop this. Yeah, so the easiest option to use, right? The easiest, because yeah, even though you are working locally, right, you're still signing transaction, and you need account to sign those transactions. Every move you make is a transaction, so you need an account to sign that transaction, right? So as you can see, pre-deployed account gave us access to that. What it does is it basically gives us access to this account that was generated. You know, when we start up Katana gives us like, I think 20, or I think about 11 or 12 accounts, right? So now this pre-deployed account gives us access to those accounts that are in Katana. So what it means is you can actually use, those accounts are already created and are available in Katana locally. So what it means is you can now use those accounts from your front end, right? And that is what this guy gives us. So over here we are specifying the RPC URL. Now, but let me show you something, right? In this game here, this game is not running locally, right? But it was able to get Katana account for me. And how is that possible is because at one point in the code base, I had to use the RPC URL of my Katana server, which is not locally in this case, which was deployed using slot. So I had to use that. I had to set the Torii URL as, no, it is not here. Though we'll get there actually, we'll get there shortly. So the deploy account gives you access to the Torii, to the account in Katana. Sorry. Now this is where you configure the provider using your RPC URL right from Dojo config, and the rest is similar to what you're already used to. So let's move on. So this is our app.csx, but we want to do something different. Let's create a new component called game. All together, guys. So let's go back to the code base and copy it again. Probably I made a mistake copying it, but let's try this once more. So yeah, this is, I think we're good. Okay, so before we, are we together, guys? Are we together?
Yes.
Are you with me? So before we start exploring the front end, right? I want to show you how you can generate these guys. How you can generate bindings, TypeScript bindings for your client. So basically, this is auto-generated. You don't have to write it, and it is generated off your models and your contract. As you can see here, this is the move and this is pawn function gotten from our contract. So let's jump right in. So if you want to generate this, right, in our case, this is where we want to store it. But basically, the first thing you do is you in your environment variable, you set where the scarp.toml is, the scarp.toml of your contract. You configure that in your environment variable. And how do you do that? You export and you set it to where your scarp.toml is. In our case, this is chase the bag / contract / So that's the first thing to do, and the second thing to do is to actually run the build command. So I added that as a command here, and this is it. So the next thing to do is to run the command, and if you look at it, we're using sozo build -- typescript -- bindings output, and this specifies where we want to store the output. So in this case, we want to store it inside our source folder. Now that is why you have this TypeScript auto-generated for you over here. So yeah, as you can see, it has generated. So even if I delete this, right, let me delete and show you that this is auto-generated. So it will generate another TypeScript folder for me with all of my TypeScript bindings, my Dojo contract. So it will first of all compile a contract. If the contract is not compiling, then you don't have I can't find it. Okay, does it actually create or it does just generate? Probably there's an issue. Let me see. Let's do that once more. Let me see. Let me see. Probably it's. Let's check for models. Oh, no. It actually created it outside of our project. Meanwhile, this is not what we want. Okay, I didn't configure this properly. So it's supposed to be inside source. Or better still, what I like to do, right, is to run this command inside my client. Yeah, if you run it inside your, so that will generate the TypeScript bindings for us around here. So let's just wait a little bit. Yeah. So as you can see, it generated the TypeScript bindings for us. So let me delete this to avoid any form of confusion. So with our updated models, you can see the player model, score, next big bag, next bag, sorry. So yeah, that is how you generate the bindings for your Dojo contracts. So let's move on to game. Now, inside this game, this is where the main stuff is happening. Right, all together. So let me quickly run through this game. The code is available, right? You can come and check it out on your own over here on GitHub. The same code. So this is the game. Right, the first thing we want to do is to set the grid size 8, the cell pixels just for UI, just for aesthetics. Now I want you to look at this Dojo SDK, right? This is what gives us access to our client, and this client is where you can call your move, all of your contract functions from, right? So that's the first thing I want you to know, that this client that we configured here, yeah, if you look at this particular guy, this setup world, you can see that it returns action, and inside the action there is the move and the spawn function. Alright, so when you call client over here, you are requesting access to that client that you defined in your SDK configuration. And account over here is using whichever connected account. Now, you know, in our Starknet provider, we configured the account to use the account that we got from Katana. So that is what this guy is doing, is basically reading from that account and getting the current connected account. Now, one thing I want you to know about entities, if you go back to let's go back to models. If you look at this player model now, it has this player key. Look at this position model, it has this position key. So now this player model now has only one key, but you know it is very possible for your models to have more than one key, right? So an entity is the hash of the various keys in your model. But in our case now, our player model has only one key. So that's why we are passing, now I want to generate an entity ID over here. That's why we are passing only the account address, because that is the only key in our player and our position model. So what we want to do here, right, is to read this particular player's, read this, using the entity ID, right, which was gotten from the account address. We want to read this player details from the model, from the player model. And similarly, we're doing the same for position model. Use model is imported from React SDK, the Dojo Engine React SDK. So yeah, this is how you get access to the player and both the position, right, using the player address as the key, right, all together. Because if you notice here, let me zoom out. Now let me show you something. Just note whatever you have here. This player is currently at 5.6, right, coordinate 5.6, and the bag is at coordinate 3.2, and the score is 21. But if I disconnect and connect another player, it's now different. This is now at 5.3, bag is now at 4.5, score is 8. So if I connect another player, you will see a different result. So it is because we are using the address that was connected to get an entity ID, and using the entity ID to query the model. So this is how you query your models from your front end. So we'll come back to this function, we'll come back to this, come back to this. Yeah, so I want to show you something. This wallet account, right, is a component that we created over here. Now the wallet account, it will behave the same way if you are, let's say, similar, even if you're connected even if you're connected to the controller wallet, right? The main thing is just the RPC URL. So yeah, this is a custom component that we created, and these connectors was gotten from the Starknet provider. If you look at the Starknet config, right over here, this is where we specify the connectors, and in our case, connector is just one. But if you want your game to support other wallets like Agent, Bravos, this is where you add them, right? Are we together?
Yes, sir.
So because we only have one connector, it basically maps, loops only once and shows the connector name. Or rather in our case, we have I think this basically gives us access to all of the accounts, right? All of the accounts in Katana, which is like 10 or 11. So it means we have access to, so these are all the connectors actually. But if you want to connect other wallets, right, in addition to controller, this is where you do it. So that is it for wallet account, and over here, this is just like a condition that checks if if the account has been connected, right? So you know, if I've not connected, there's no spawn button here because spawn requires an account. So when I click on, when I connect an account, that's when I get access to the spawn button and disconnect. So that's what this guy is doing. So whenever I click on this button, it actually calls the spawn function from our contract. And how does it do that? It uses this client. And you know, I already told you where this client was auto-generated inside contracts. So it is this spawn function. That spawn function calls this particular function. So if you look at it, right, it is similar to what you're already used to in Starknet.js, but just with a little addition. In this case, it's calling provider to execute, passing the account, the call data, right, and the namespace. And yeah, this is the namespace. So it's the same provider that executes that you are already used to. So it means calling this spawn function actually spawns a new player. But you know, in our contract, we added a condition that says if the player has already been spawned, we should throw an error. This line 39 here, if player does score is less than 1, aside that player does score is less than 1. So this is now, but you notice that we are clicking on it, but nothing is happening. But if you come to the console of our browser, you see a lot of errors there. And what's the cause of the error? It's because now if you look at this particular part of the error, it says already spawned. Yeah, there are better ways of doing that. So this is already spawned, right, which is exactly what we're expecting from here, from our actions. So now there are better ways of doing it. There are better ways of doing it, right? So what it means is you can basically come over here. Now this is actually logging the error in the console, right? But you can add like a try catch. Yeah, you can add a try catch because this is where we are doing it. So you can add like a try catch, right? That actually catches this error, and then won't be able to do it over here. But I just want to show you to have an idea. So you can catch the error, and then you can maybe create a function called pass error. Then you pass in this error. Now you can simply, since this is logging as an object, as a JSON object, you can either take it and filter out, right, whatever, just using this string. Now you can take this as a text or as a string, just filter out if it matches this particular error. Right, in that case now you can maybe store all of your errors in a particular place. I already spawned and the rest. So what you do is you just come here and loop in this function. You loop over all those errors, and in each of them you'll be checking if any of those error, the string in that, any of the error message matches with whatever was outputted here. So if it matches, you output it to the UI and says okay, not connected. Like for instance, in this game, that is exactly what we did. I don't think I can bring up anything that will. Let me see if I can. Okay, I'm not logged in, right? But when you're playing the game, right, and you, in some scenarios, right, you get like custom errors that gets that just pops up at this bottom right corner. So that is how we're able to like get those specifically. We're able to filter out those specific custom errors. Okay, so now we'll talk about that when we get to move. Yeah, because it is during the process of moving that we're experiencing that lag. But so yeah, when you click, it calls the spawn function in your contract and spawns a new player. So now, this particular part, right, this is like just UI. This is basically the UI that renders the grid. Now this is another important part of the front end I want to show you. Right, if you notice, over here we created the player and the position variables that are used to hold these players' details and the player's position details. Right, so this is how we are reading from me to do player.vec.x, because in the model, right, in the model, right, this player, okay, no. The position, right, in the player, in the position model, right, there's a field called vector, and that vector also has another field called x. So that's why we are using position.vec.x and position.vec.y. And similar for player.nextBigBag.x. Next bag, I'm always saying next big bag.
How did you get position? Is it from the provider?
Position.
Okay,
this is where I got position, and how did I get it? I'm using the entity, right? I'm using the entity ID that was gotten from this player address to query the model, right? Using this hook. So I'm querying this particular position model using the entity ID. So it will give me this specific player's position, right, in the model, because I created an entity ID from the address of the player. Now, I told you you can create, and I told you the hash of the keys in your model, right, will give you an entity ID. So if your model has like more than one keys, right, now in this case now you shouldn't use just the player address, you should use the other key. Let's say that's like a username. Let's say username. Now this player model has two keys, right? So in this case, this user entity ID takes in an right? So what you should do is to just pass in username. whatever it is. So you get the entity ID and use it to query player model. So that's how you do it. What did I do? I hope I didn't mess that up. Let me see. No, I didn't. Yeah, so let me take this out. So the same thing happened in position as well, because our position model has only one key, which is the player address. That's why we're using the same entity ID that was gotten from the player address to query the position model for this particular player's position. So yeah, let's go back to this lines that I skipped. Yeah, so this basically undoes the key down event, so it allows me to be able to just use my arrow keys to navigate the canvas. So that's it for this use effect. So let's talk about render grid. Now render grid is simply a nested loop that renders this 8x8 grid for us. So let's see the content of it. Now this is where we are reading the player and the bag position. So we are checking the position of the player and the bag, and that is why, you know, the grid knows to position the bag here. That's why it knows to position the player here, right? Because it's reading from this guy over here, reading from the player's next pick bag, X and Y coordinates, right? And also the player's position as well. Yeah, so the rest is just React and Tailwind. So let's look at the last function here. Use entity query. So this is like a query language built by the Dojo team. So what it does is it allows you to query your models, it allows you to query your world. So in our case now, we are using the key clause to, in the query builder to generate a query. So as you can see over here, right, now this key clause takes in 3 arguments. First one is the model, second one is the keys, third one is whether it is fixed or variable length. In our case, we want it to be fixed length, but fixed or variable length, like variable, fixed or variable length means you want to query for this specific number of keys, right? For fixed length, if it is this specific number of keys. For variable length, if you want it to query for where there's more keys than what you are querying for, right? So now we want to query for both the player and the position models. Now, of course, you know, we got models mapping from this auto-generated model file, right? So that's what we got it. So if you want to query for any model, you just get it from model mapping and pass it over here. Now this is the keys, right? You can add as many keys as you want because this is an array, right? But in our case, we are passing in the account address because both the player and the position has account address as their keys. Yeah. And you might want address, add address padding. Basically, it helps you add 0. It just pads your address in order to fill to get the length. Right? Let's say sometimes these addresses that are generated don't actually, they're not long enough to, you know, the lengths, right, are not the same, right? And because you're searching here, what it means is you're matching, right? So in your Dojo world now, the address that was generated there might have like 2, might not have any zeros, but the one you want to use to search for it might have like, okay, let's say the one that was in your Dojo world now might have address padding, right? They might have padded the address, right, in order to meet the required length. but the one you got maybe from your wallet or from any other wallet or account you're using might not have been padded. So what this address padding does is it basically adds padding to your address, so it transforms this kind of address. You can see this one 0x9, but when you pass it, it goes to 0x00009. So the reason for doing that is just to match the addresses effectively. So this is the query language built by the Dojo team, but you can check it out in the documentation, and yeah, just check Dojo.js. I think Dojo.js, it's in the Dojo.js section of the documentation. Yeah, so this is the last function we'll check, is the undo key down function. So what this function does is that guy that gets called in your front end whenever you click on any key, right? Currently we configure it to listen for only the arrow keys, right? Are you with me? Are we together?
Yes, sir.
So we configure it to listen for only the arrow key. So as you can see, whenever you click on arrow up, right, sets a direction to new to a Cairo custom Cairo enum with setting the default value as up. Now I want you to note something, right? If you can look at this clearly, you will see that we are using Cairo custom enum, right, for the direction, right? The same thing happens for down, left, and right. And when we want to call the move function, we're passing this direction that is made up of this Cairo custom enum. So now, but if you go back to your move function, right, you will notice that we're expecting an enum. This is a move function. We're expecting a direction, and direction is a custom enum, right? So what does this tell you? This tells you that this is how you can send enum values into your contract, right? If you have a contract function expecting an enum, like direction for instance, this is how you can compose that value and send it to your contract. Are we together? Are you with me? So yeah, whenever a key down event happens, it sets the direction to that particular key and call this move function. So this is where the move function is being called, right? It calls the move function, the move function executes and get random position, and immediately it triggers an update to your client using Torii. Node.js, yeah.
Instead of this separating these two clients, can we add something like templates like EJS, Adu, or templates, HTML templates like that? Just have everything under our contract instead of these clients.
Okay, instead of clients, you want to have it.
Something like that.
I don't think so.
So that would be more faster. Because this is another action like that. This is another like stress like that.
Yeah.
There's something like real world project like that.
Yeah, but in a real world project, like especially in large scale games, you most likely want to separate your modules and everything in order for the project to scale efficiently.
So I'm looking for a project I can build that with character. Just need to release my Cairo, and I can use any engine as in like for preview.
Yeah, sure. Dojo.js, apart from Dojo.js, right? Dojo allows you to connect to your contract to its other tools like Unity, Unreal Engine. So if you come to the documentation, you can see all of them. Yeah, you can even connect it with Telegram, connect it with Discord, connect it with Unreal Unity. So Dojo.js is like one of them, right? So you can definitely check it out. And
Just drop down the Dojo.js.
Yeah, so this is where you can learn more about the query, the Dojo query. Okay, so this is where you call the move function, right? So you pass in the account and direction, and so what it means is whenever I click on any of my arrow keys, it is this particular function that gets called. This function is in our contract, so we'll call it from our contract and pass in the necessary argument. So that is what happens, and that is why, yeah, that is why this works. So let me see, are we missing anything? So let me run this. I just hope we are not missing anything. So let's access it at localhost. It's HTTP, not HTTPS. So yeah, we are missing something. And what is it we are missing? Let's check it out. Are we together? Are you guys still with me? Okay, split. Let me see, where is this guy coming from? 49.19. Okay, no, we are not using, we are going to delete this app.tsx because we are not going to use it. So let's simply replace this with game, and let's see if everything is up. Yeah, so it looks like we are good to go. So this is running on localhost, and this is connected to my local Katana, right? This particular UI is connected to this Katana that I'm running locally, Katana and Torii specifically. So yeah, let me connect and spawn and move. So I think Torii has maybe an issue with spamming it. Maybe if he spams it, it just shuts down. But yeah, this is no, disconnect. Let me spawn again. So this is how it works locally. So this is how it works locally. Did you guys notice something? What do you guys notice about this local version compared to the faster, right? Because this is running locally, right? So I'll just also, okay, I think I'm going to like investigate why Torii is always stopping, but yeah, it's not something that can hold us back now. So let me just connect, spawn another account, spawn. So guys, is there any question? So this particular version of the game is running locally, but this version of the game is running remotely. I already deployed this. So you might be wondering, how did I deploy this, right? How did I get access to Torii and Katana out of my environment, out of my local host? So that's where slot comes in, right? In the last class, we tried to use slot, right? So we'll finalize on that now. So let's quickly finalize on that. So I will be stopping this local Torii and Katana, and I'll be showing you how you can use slots to deploy and interact with your app. So I can basically show you this from a Vercel, I can deploy it to Vercel and show you a link because of slots Yeah, because of slots basically. So let's do that right now. Do I need this? Okay, I can just simply use this. Yeah, so how can you deploy to slots? First thing I want you to notice your profile in your Dojo Contract section. Mostly when you want to deploy to slot, it should be the release profile, right? It should be the release profile. Secondly, you should take note of this seed, right? This seed must be unique, like universally unique. So I believe somebody might have used Dojo Starter, but let me use Chase Debug. But let me just make it more, get more guarantee that this is unique by adding a 99 here. Are we together? So yeah, if you notice, this is on the release profile and not on dev. So the first thing I'll do is I'll create a Katana deployment. And how can I do that? The commands are, if you can go to controller docs to like explore the various ways that you can use slots, right? But I already have the commands here, so I'll just simply copy it. So I'll copy this command. So let's use the same name, because this is like creating an instance of Katana in cartridge infrastructure. So it's similar to the Katana we had locally, but this is available remotely. So I'm going to use the same name, and lastly, I'll be running this in dev mode. Oh my, I've reached my limit. So let me see if I've used the limit in my other accounts. Let me see if I've used the limit in this particular account. So I think I have, in this particular account, I think I still have some, yeah, I think I still have some deployment. I think I can still deploy from this account, so. Yeah, but you can actually, if you go to slots, I think, so you can actually create a team on slots. If you say slots -- help, maybe if you run out of deployment tokens, right, you can say slots -help. Yeah, I think with the slot teams you can maybe just check the documentation though, but I think it's either teams or account. But basically, if you run out of deployment tokens, you can just create a team and maybe subscribe to a paid tier, because I think by default your account get like only 3 chance to deploy using slots. So if you exhaust this opportunity, you can actually upgrade your account and get access to deploy more. So this is our slots deployment. We've successfully deployed Katana. So what this means is you come to your release profile, you replace whatever is here with your Katana deployment. Are we together?
Yes, sir.
Now after you replace that, right, you build and you migrate this project again, but this time not on your dev profile but on your release profile. So this is how you do it. So build. So it will first of all build, and you also do the same thing, right, while migrating. Now, if you notice, right, it specified that we are migrating this particular project to a particular Katana deployment. So this is the RPC URL, right, and it is here because we specified the RPC URL over here. So this will take some time, and so this is the last stage, right, of this particular session. So we just want to deploy our contract to Torii and get access to it from our front end. So this is the word address that was given to us, and the next thing to do is to deploy to create another Torii instance, right? So we can do that from here. But in this case, the word address needs to be updated, and the project name as well. So let's use same name. Okay, I need to add one more argument, which is RPC. So because this my contract was deployed to this particular RPC URL, so I'm gonna specify the RPC here. So this will take you a few seconds to, create a Katana instance that is indexing our Dojo contracts. So to give us a URL, and yeah, deployment successful. Are we together, guys? So yeah, deployment was successful. So it means this is our new Torii URL, and this is our Katana URL. So in our front end now, if we want to directly access this Torii and Katana that we just deployed, we can come to this particular. First of all, we open Dojo config, right? So just as I said earlier on, you replace this with Torii URL, and you replace this with Katana. Let me get the Katana URL. So you replace this with Katana URL. Right, so it means this is not like looking at our local Torii and Katana. It's not looking for the one we just deployed, right? So one last thing you should do, right, is to come over to this SDK session and Torii, yeah. You should set the Torii URL to whatever your Torii URL is. So let's go back to Dojo config. And get this Torii URL. Or we can even easily, instead of that, we can say dojo config dot manifest dot dojo config dot Torii URL. So let's check this out. Let's check the progress. Let's refresh this page. So now you can see that after refreshing this page, I still get access to my account, right? And I'm no longer reading from the local katana. I mean the katana that I spun up initially. They are no longer active, right? They are no longer active. So what it means is this account, right? I'm reading them from my remote Torii deployment and katana deployment as well. Now if you check let me spawn. Now if you check it's not deployed, seems like, okay, just one more thing, right? You know, I told you earlier on that this manifest, right, is something you should take note of, right, whenever you are switching profiles. Like in our case now, we switched from dev profile to release profile, so we need to also update this as well. So this should work. Click on account 2, spawn. Yeah, so this is expected to work, and as you can see, it just spawned the new player for us. Right, so if you look at the network tab, you can see that Katana is sending requests for Katana, it's sending requests to our Katana deployment. And also, if you look at the Torii, it's also sending requests to our Torii deployment. So that is how you verify that this is actually running on your Katana and Torii deployment. So, altogether, is there any question? So you can even play this game like as a multiplayer game, right? So when you come here, so this is how it works, right? Where update is being synced between the two players. So if you notice, right, let me show you something. Let me connect this guy to 3. Connect this guy to, okay, no, 3. To the same 3. So if you notice something, you'll notice that the update is being synced between the two players, right? So over here, if I move, I'm currently controlling the left window, but the update is reflecting. Now you can see these are like like they're on the same domain but different tabs, right? So this is how you can build a multiplayer game on Dojo engine. You can see that the update is being synced between the two clients. So that will be all from me. Is there any question? Do we have any question or anything you are not clear about? So without any question, let's call it a day. Thank you.